We will discuss the concept of API testing, its benefits, and the various types of API testing that we can perform to provide bug-free APIs. Now, what is API testing? API testing is a set of quality assurance actions that include sending calls to the API, getting output and validating the system's response against the defined input parameters, in particular, the accuracy of the data and its format, HTTP status codes, and error codes. The approach to API testing largely depends on the API type. We have different types of API, which includes web APIs, database APIs, operating system APIs, and remote APIs, among others. As such, there are different testing strategies for these classes of APIs. Now let's discuss some of the benefits that we can realize by testing our APIs. We test an API to verify that it exhibits the required functionality and it seamlessly integrates with other applications or services. Simply put, with tested APIs, we can ensure that the APIs will do exactly what they're supposed to do. Another important aspect of API testing is to ensure that the API can handle a given load. We test APIs with varying loads to ensure that its performance doesn't degrade or, worse, break down. As such, tested APIs function well, even under varying load stress. Usually, APIs are tested for interoperability, so with well-tested APIs, we can ensure that they work across different devices, browsers, and operating systems without any issues. So far, we know what API testing is and the benefits of thoroughly testing APIs. Now let's discuss how we perform API tests, for which we'll be using the sample illustration figure, which depicts the steps involved in a generic API testing approach. The first step in API testing is to review the API specification and the use case documentation from a test perspective. In this step, we need to determine the testing boundaries and requirements. After having reviewed the API specification, we need to develop the test specification as per the API requirements. The test specification will contain the details of the test conditions and the expected results for each test case. Apart from that, it will also contain the functional scope of the API. Having developed the test specification, the third step is to set up the test framework, where we will create the test environment. Setting up the test framework requires the configuration of the servers, databases, and other resources the API interacts with. To this end, we can use standard open-source tools like SoapUI, JMeter, or Postman, among many others. Now, after setting up the test environment using the framework of our choice, the fourth step is to write the test suites, which generally contain multiple test cases. In the test cases, we specify various test scenarios to validate the performance, functionality, sanity, security, and other aspects of the API. The final step involved in API testing is to execute the test suites that we've developed and generate the relevant test reports, which we can then review to understand how well the API performed during the tests. There are different types of API testing that we can perform as well. So let's discuss some of the different types of tests that we can perform for APIs. In API testing, we check if an application returns correct outputs in the expected format, if it delivers responses with an acceptable time frame, and how well it integrates with other services. We also need to check the API's response for extreme cases of potential security attacks. So there are different types of tests to cover all these aspects of the API. First, we have the functional API test, where we assess specific functions within the code base. It ensures that the API actually works within expected parameters, meaning it returns the desired output for a given input and handles errors when the results are outside the expected parameters. Under functional testing, we have subtypes, such as positive testing and negative testing. While a negative testing checks how an API responds to wrong inputs, positive testing verifies the correct functioning of the API with correct inputs. Next, we have API performance tests. To ensure that an API can handle the expected or higher load, we validate its functionality and performance by artificially creating or simulating API calls. API performance testing includes other subtypes, such as load testing, stress testing, and scalability testing, among others. The third type of API testing is the API security tests, where we diagnose API vulnerabilities against external threats. This test consists of other subtests to validate different security concerns. For instance, we have security testing to check if security requirements like authentication, permissions, and access controls are met. We also have penetration testing for securing the API functions, resources, and processes against attacks, and fuzz testing to test the endurance of the API's overall security. Finally, we have API integration and reliability tests. We know that API components communicate with each other and other external services using APIs. As such, APIs need to pass both the integration test and reliability test. Integration test ensures that application components are well connected and don't create bugs in another API's modules. Reliability test, on the other hand, checks if the API-based application can perform a failure-free operation for a specified time period in a particular environment. Now that we are aware of what API testing is, the benefits of API testing, how to perform API testing, and the different types of testing that we can perform to test every aspect of an API's functionality, let's explore some of the prominent tools that we can use to test APIs. To begin, we have Postman, which is one of the more popular tools used in API testing. It provides integrated test automation features that has a friendly UI for constructing requests and reading responses. Postman runs on local machines. As such, we can remain in control of our data. Using its command line tool, we can integrate tests in continuous integration environments. Next, we have JMeter, an open source tool for automated testing. We can perform performance testing of RESTful services with the use of JMeter scripting, and it supports different languages like Java, JavaScript, and PHP. With JMeter, we don't have to create boilerplate code to test and validate complex REST responses. SOAP UI is another prominent API testing tool for testing web services. It can be used to test both SOAP web services as well as RESTful web services. SOAP UI is a reliable tool which is easy to learn and use. Using this tool, we can asynchronously test APIs before they are implemented. Finally, we have Catalan Studio, an automation testing tool for web, API, and mobile. Unlike other testing tools like Selenium and RainerX, it doesn't need additional integrations to test APIs. And with Catalan, we can test all types of REST and SOAP requests. Now, to conclude this video, let's explore the API test actions that are required for functional testing an HTTP REST API. We mentioned earlier that functional testing consists of subtypes or categories of other tests, like positive testing and negative testing, among others. Each of these tests can be automated testing or manual testing, and they are comprised of test actions. These are individual actions a test needs to take per API request. The first test action is to verify if the HTTP status code is correct. For instance, creating a resource should return 201 created, and unpermitted requests should return 403 forbidden. The second test action is to verify the response payload. We need to ensure that we get a valid JSON body and correct field names, types, and values. Following that, the third test action is to verify the response headers. HTTP server headers have implications on both security and performance. Next, the fourth test action is to verify that we have the correct application state. This state action is optional and applies mainly to manual testing or other tests which can be manually inspected. The final test action is to verify the basic performance sanity of HTTP APIs. An important goal of this test is to verify the rationale of a performance. For instance, if an operation was completed successfully but took an unreasonable amount of time, the test fails.